Perfect. Good morning, everybody. Thank you very much for attending this session. As an introductory note, I'd like to just thank the South African Bitumen Association for their continued financial and technical support for this work. And I'd also like to acknowledge my co-author and PhD supervisor, Professor Don Ross. The presentation which we're giving today is on an economics-based road classification system for South Africa. Now, this talk, I think, is well placed at the end of the conference in that it brings together a number of the different elements which we've discussed over the last few days. It brings together the pavement preservation systems, it brings together pavement preservation techniques and methods, and it also focuses very much on users at the heart of the system. What we are trying to do in this methodology with this new classification system is to efficiently provide a network that the economy and that the users are demanding. So, whilst the method is also applied specifically to South Africa, what I would like to say is that the methodology and the techniques that are used are relevant across countries, so that there should be wide application for this work. In terms of today's presentation, what we're going to be focusing on is initially just scoping the problem. Then we're going to go through the classification criteria, the different classes, a prioritization rule in terms of ordering those classes in terms of a maintenance priority, and then we'll spend just some time going through each of the different classes so that you can get an indication of the characteristics of those classes. And then finally, we'll touch on how to apply this new system and how it interfaces with pavement management systems. So in terms of the problem statement, what I'd like to do is just for 1 second for all of us to imagine that we are in a country which has a deteriorated road network and that country also faces large road budget deficits. Now, it's not hard to imagine that because that reality applies to many countries which are represented at this conference. Now, within that context, it becomes problematic if there's a mismatch between network objectives and the road classification systems, because that makes it difficult for road authorities to direct expenditure towards specific types of road classes which are being demanded by the users. The two specific types of road classes which the South African network is mandated to provide are roads that satisfy citizens' constitutional rights to access basic services, and also roads that maximize economic growth. Again, whilst those are South African mandates, those are generally applicable to most countries. In terms of the classification systems that are currently available, functional classification looks at mobility access, distinction between roads. An administrative classification system looks at which is the responsible authority. Geometric systems look at structural characteristics. Naming hierarchies look at trying to order and class roads according to specific naming types. Road traffic sign systems very crudely look at traffic volumes and assign roads to those classes based along those lines. And route number systems look at ownership and route types, such as tourist routes. Now, what is missing from all of these systems is that they all exclude the purpose of the trip. So, what are the users using those roads for? They also ignore connected infrastructure. So, what services are these roads specifically connected to? They also lack specific mention of the value of traffic and crudely account traffic volumes. So there's not an accurate indication of the economic value of a road within these classification systems. So in moving on to creating a new classification system that takes consideration of the basic access function of a road and also a road network's mandate to maximize economic growth, there are certain criteria that need to be adhered to so that the classification system is functional, efficient, and usable. The first of these is a small number of road classes. This is so that it's easy for officials to use, so that the system's functional. But critically here, the system that gets developed needs to be simple, but it cannot, in the process of simplification, exclude any class that is theoretically relevant. The second fundamental classification criteria is that the network, that the system needs to be unambiguous, use unambiguous descriptive terminology for road classes. So the different class types need to have clear, concise, distinct, and objective definitions. The last one which we applied was classes need to be scale-free and ubiquitous across the network. The entire network must be consistently classified. That's very important, that there cannot be any regional distinctions between the classifications. And then a last classification criteria which we felt wasn't applicable is hierarchical contiguity. So here, what this is trying to achieve is that roads of the same class connect to form a continuous network. However, in doing that, you would undermine efficiencies obtainable from prioritizing across an entire network. So there may be roads which are owned by a different authority or managed by a different authority, which are in a different class, which may provide a better connection than roads owned by that same authority. So prioritizing across a network as a whole allows us to realize efficiencies. Moving on to the economic classes which we've developed, what I'd like to do in this slide is to just give you an overview of the main characteristics, the different class types, which speak to the user groups, and then the main characteristics which are applied or relevant to each. So the first class of roads which we established were basic access roads. These roads, critically, there are no alternative access routes to access basic services. So these are the roads which users are reliant on to reach essential services. And as I say, essentially, there are no alternatives. In saying that, there are also then rural roads, because in the urban areas, there are alternative routes that are available. And the basic access roads also reflect access norms and standards. So in South Africa, there are prescribed access norms and standards, which state specific distances within which road authorities are mandated to provide roads. For schools, which is the only prescribed one for basic service, it's up to 5 kilometers of a school. And from there, the authorities are not legally mandated to provide roads or further connections. The next class is strategic roads, which are high-volume transport routes. They have inelastic user demand, which means that your traffic volumes do not move in line with the business cycle. They stay consistent. And then they also include urban roads. Then tactical roads, which are low to medium traffic volume roads. These roads, in distinction to the strategic roads, have elastic traffic volumes, meaning that as the business cycle moves, traffic volumes also fluctuate. So these roads can be prone to moving traffic volumes and moving economic contributions. And then these roads are rural and peri-urban roads. And then the last set of roads is surplus roads, which have no basic access function and in fact make a negative contribution to economic growth. So that's an overview of the classes. In terms of a prioritization rule, so in terms of this order in which authorities should address these different road classes and the different user needs, the prioritization rule which we've developed is based on normative reasoning, and it's on both philosophical and economic arguments that prioritization of basic access roads takes precedent. So in that first class of roads, which are the basic access roads, they're split into two different groups. The first is a multifunctional basic access road, and that is a road which not only facilitates access to basic services, but also provides an economic function in terms of contributing positively to the economy. Those roads are ideal in the fact that they allow authorities to address both mandates simultaneously. Then there's single function basic access roads. These are roads which purely perform just a basic access function and in fact make a negative economic contribution. These are roads which we'd like to minimize as they detract resources from more valuable roads. And as a side exercise to doing that, we have optimized service center locations to try and put service centers in the ideal location to minimize instances of single function basic access roads. Then in terms of the next set of priorities, it's economic growth. And the economic growth roads are, as I said, divided into strategic roads, which are providing higher levels of traffic, high levels of economic contributions, and are serving structural traffic volumes. They are given priority over tactical roads, which are serving lower traffic volumes, and as cyclical fluctuations happen in the business cycle, their contribution to the economy also reacts accordingly. And then the last priority is surplus roads, and these are the roads with no basic access or economic growth function. Just a quick overview of the different classes and the analysis that we've done in South Africa is basic access roads were also a tool to regulate the rates of rural-urban migration, in the sense that if you're able to provide decent connections to basic services in the rural areas, it stops forced migration to access those essential services. So it was a useful tool, especially in South Africa, where rural-urban migration is happening at a rate faster than urban centers are able to accommodate in terms of their infrastructure. It's a very useful set of roads to provide, in addition to obviously the constitutional obligation. Then I've put an estimation methodology in here, which is how we located these roads in the South African context. And we used GIS locations of all schools and healthcare facilities. We used network analysis to determine the fastest access routes to these services from each individual household location. We removed medium and high volume roads, which was a proxy for the sort of economic contribution of roads. And then we removed the urban road network as well. And lastly, we controlled for access norms and standards. So we were also cognizant of the fact that there does need to be a certain level of direct access to schools and hospitals. So we have provided a minimum level of direct access so that there is that service provided. Now, an important finding from our work here is that in South Africa, only 8.2% of the total road network appeared as basic access roads. Now, this is vital because this allows the South African road authorities to address this class of roads, to address this class of user demand, and to do that within an amount of budget that still leaves enough available to allow the network to still facilitate and support economic growth targets. So that was an important finding. And then the other important finding about that 8.2% is additional research which we've done suggests that, or indicates that all roads in the South African network, if they're worth maintaining, should be sealed. So because it's 8.2% of the network, because they can accommodate it within budget standards, it means that that sealing of the network can and should happen within at least the medium term. And we were hoping that that should make the asphalt providers quite happy. Then moving on to the strategic road network, these are typically roads which carry 10,000 vehicles or more per day. They support structural economic activities. And the important thing as well is that this classification includes more than just the national road network, which is typically what your normal distinctions do. They just classify the national network as the strategic network. But what we've done is we've included all roads which are core economic contributors. So it's got the urban network, it's got key trade routes, it's got links between major cities and towns. So it's a comprehensive picture of the strategic backbone required for the South African economy. And then the estimation methodology looked at the core strategic network, looked at the primary strategic network, which is the high-volume alternative routes to the core network. primary road network, which are feeders to the core and secondary networks, and then it also included all of the urban roads. And this is an estimation on the right, just graphically illustrated. Then in terms of the tactical road network, traffic volumes, as I mentioned, are low on tactical roads and strategic roads, with the exception of some urban roads, which will be carrying slightly lower volumes than some of the high-volume tactical roads. But this network is still essential, as many service centers and origins of goods, the trading routes and destinations are located along these secondary and tertiary roads. Now, a very important element to the work is that tactical roads essentially need to provide a positive economic contribution. And the work goes into a further level of clarity and detail here in terms of clarifying and estimating the economic contribution of roads by developing a structural growth model. And the structural growth model comprises two terms. The first being you look at the expected cost of a road, and that cost is in terms of its expected future maintenance. And then you compare that with the road's contribution to economic growth. And that economic contribution to growth is more than traffic volumes. It's got to do with the value of cargo, the goods being moved, and the relationship of those goods being moved to economic imperatives in the country as well. So are they export-orientated goods, which, as an example, is an imperative in South Africa? Then this is my second last slide. I don't know what has happened, but it's not a problem. So the surplus road network, these roads make a negative contribution to economic growth, determined using the same structural growth model as I previously explained. Now, the critical point about this road class and identifying it is that it's not serving any user's basic access functions. There are no citizens relying on these roads to access a basic service. Once we are aware of that fact, and we also know that these roads contribute negatively to growth, we're able to strip them from the network, unproclaim them, and free the resources that were being allocated to them to more productive roads. Now, that is something which I think is relevant in many countries, especially where networks have swelled as a consequence of expanded public works programs and just legacy. So in South Africa, that's one way which we're looking at trying to make the limited resources which we have go further and service the users better. And then just as a last point, it is important for authorities to officially unproclaim those roads, as road authorities are making decisions in isolation from other departments. It's not a problem. I've got my last slide. No, it's not a problem. So, as I say, the road authorities are making decisions in isolation from other departments. So, if it is not officially an unproclaimed road, it may be the case that a school or a healthcare clinic is located along that route. So, for this to be a formal procedure which authorities follow to maximize user experience and the efficiency of the network. And then, just a conclusion is that this is a wider project, and we have produced a full paper for this element of the work. We have also produced a number of other research elements which are potentially interesting and useful to the audience today. So thank you very much for your attention and for listening. I hope this was an interesting and positive contribution to your work, and we are happy to continue any follow-up conversations, where there's interest. So thank you very much.
Perhaps any question for Matthew? Yeah.
Let me get more.
Matthew, good job. It's always fun when your slides go out.